In this last section of the course, we are going to focus on network security. We will cover topics such as network policies, access control for the API server and the kubelet. By the end of this section, you will know what tools you can use to secure your Kubernetes cluster workloads and components. In this video, I'm going to show you what network policies are within the context of Kubernetes. I will show you what they are useful for, how they work, and what impact they have on the security posture of your cluster. If you recall from previous videos, I said that in Kubernetes all pods can communicate with one another without restrictions. By default, Kubernetes does not enforce a network communication policy on the workloads running on the cluster. So all applications that run on a cluster can talk to each other. This may or may not be a good thing. For example, you may not have a problem with the fact that an application can call another application, but on the contrary, you may realize that ring-fencing an application from a networking perspective is actually desirable. Perhaps you want to make sure that only specific pods or apps can talk to your application. Or perhaps you want to only have a subset of workloads being able to talk to your application. Well, this is where the Kubernetes network policies come into play. Network policies are Kubernetes objects which allow you to configure how groups of pods are allowed to communicate with each other and other network endpoints. In simple terms, network policies are like firewalls operating in between pods running on a Kubernetes cluster. With network policies, you can declaratively say which pods are allowed to connect to each other. You can be very specific. You can say what namespaces are allowed to communicate, or you can choose what ports the policy is enforced on. Network policies use labels to select pods, and it is important to note their implementation is not a Kubernetes core functionality. Network policies capabilities are provided by network plugins running in a cluster. If you submit a network policy object to the Kubernetes master and your network plugin does not implement network policies, it will not be enforced. Additionally, note that network policies do not apply on network packets. They apply to connections, and connections allow bidirectional transfer of network packets. For example, if pod 1 can connect to pod 2 can reply to pod 1 back on the same connection, but this does not mean that pod 2 can initiate a connection to pod 1. A network policy has essentially two main parts: target pods and ingress or egress rules. Let's go through some examples to see how they work. From the terminal window, you can see I am already logged into the master node on my machine. In the current folder, you should already have a YAML file called network policy deny all. Let's go through its content for a moment. In this network policy, we are selecting all pods with the label app set to my app. Then we are specifying an empty list of ingress whitelist rules. That basically means deny all traffic. Let's see that in action. With the network policy created, let's now test whether this actually works. If you remember from previous videos, pods could call each other without problems. Let's see whether that's still the case now. Now within the pod, let's try to call the application. Notice how the command hangs and does not return anything. Now, let's see what happens if I now go and delete the network policy. With the network policy deleted, let's go back into the pod and call the same service again to see what happens. As you can see, the app immediately sent a response. That was because there was no restriction in place anymore. Now, let's try a more contrived example. After you exit from this pod, on the current directory, you should see a file called network policy allow busybox. Let's take a look at it. In this network policy, we are saying that all pods with a label app containing the value busybox can talk to any pod with a label app containing the value myapp. Let's see that in action. I am also going to reapply the previous network policy to prove this point. With the network policies created, let's go into the busybox pod and see whether we can reach the other pod. As you can see, we can call the other pod just fine. Now let's test this further by going into the nginx container. If the network policy is working correctly, we should not be able to reach the target pod from there. Now let's do a final test. I will now delete the network policy that allows access from the busybox pod. And with the network policy deleted, let's now try to reach the app again from the busybox pod. As you can see, we can no longer communicate with the target pod.